Hello dear students. In the last class we discussed about electric energy, isn't it? Today we are going to discuss about a very small topic, heating effect of electric current. What happens if you charge your mobile charger for a long time? If you charge your mobile for a long time, when we touch that charger, we can feel a heatness, isn't it? We'll feel heat. The mobile charger will be hot. Or if we use the mobile for a long time, when we touch the back side of the mobile, we'll be feeling heat. Some hot, it will be hot, isn't it? So why this mobile or why this electrical equipments, after running a lot of time, why it becomes heat? That thing we are discussing today. See, before going to that section, let us come to the internal structure of a conductor. Let it be any conductor, iron, copper or something which is used to make any object. So it consists of electrons and free ions will be here. Free ions will be here. So this consists of electrons and free ions. What happens when we apply a potential difference across the conductor? When we apply a potential difference, that means we give connection to a battery. So we are applying a potential difference. So what happens? The electrons from the negative end, electrons are negatively charged particles, they move from the negative end to the positive end, isn't it? They move from the negative end to the positive end, and as a result a current flow will be in opposite direction. In which direction? Electron will be moving from negative to positive and current will be moving from positive to negative. This thing we already discussed. Anyhow, that happens when we apply a potential difference across this conductor, isn't it? So see, when the electrons are moving from this negative terminal to the positive terminal or low potential to high potential, what happens here? See, the electrons will collide with some other electrons and also with the ions present inside the conductor, isn't it? When they start to move towards the positive end, they will collide with some other electrons and also with the ions which are present inside the conductor. So while they are colliding, a heat is produced, isn't it? When we are colliding each other, what happens? There will be a destruction. At the same time, there will be a production of heat. As like that, when the electrons collide each other, they produce, and electrons collide with ions too. So at the time of collision, it produces heat. This is how heat is produced in electrical equipments. So in some of the equipments, heating effects is desirable, which is good for us. In some other equipments, it is not good for us. First, let us discuss where it is good for us. In an iron box, electric iron, it is working only with the heating effect of electric current. The basic principle behind working of electric iron is, what is that? Heating effect of electric current. Electric heater, you know what is electric heater? That is used to boil the water. So such type of making heat the water. So this type of devices which also work on the basic principle. This is also based on the basic principle which is heating effect of electric current. Electric furnaces will be the large vessels to heat the water in order to produce steam, and such type of large vessels will be the electric furnaces. So these type of devices, they work on the basic principle, and even the electric, what we can say, electric cookers, what is its name? Easy cook, such type of electric cookers. So these are all based on the basic principle, heating effects of electric current, isn't it? Now, so these are desirable qualities. Because of only heating effect of electric current, we are able to produce and we are able to use this device. In some other devices, it is not desirable. For example, our mobile phone itself, it is not desirable when it heats so fast. Electric motor or fan, this type of things. And even bulb, bulb work with the effect of electric current. It consists of a filament inside it. Mainly this filament is made from a metal called tungsten. And this also work with the help of heating effect of electric current. When this tungsten become hot, it start to produce light and heat. So that is the basic principle behind glowing of bulb, that is heating effect of electric current. So heating effect of electric current have both negative sides and positive sides. Sometimes we are using this heating effect of electric current to produce some of the equipments. Now we can discuss what happens or on which factors this heating effect depends upon. Firstly, if more current flows through the circuit, if more electrons are moving through the circuit, what happens? There will be chance for more collision. So if number of electrons increased, if number of electrons are increased, more heat will be produced. Number of electrons, if number of electrons is increased, that means that electric current flowing through the circuit is increased. So if more current is passing through the circuit, that means there will be a chance of more heat production. Second dependency factor is that if the resistance of the conductor or resistance of the material we took is greater. A material which possesses high resistance means that it consists of large number of ions. So there will be more chance for collisions and thus more heat will be produced. So if the resistance of the specified conductor that we took, if it is in increased amount, if the resistance is increased, then heat too will be increased. Third one, time. How it depends upon time? If we use a device for a long time, it may also lead for increasing the heating effect. So it depends upon time. These three factors, first one electric current, second one resistance, and third one time. So based on that, we can make a relation, that is heating is directly proportional to I square RT. Are you familiar with this equation anywhere? I square RT. Yesterday, while we were discussing about work, electric energy, W equal to I square RT, we discussed that, isn't it? So similarly, actually this heat is the work done by the electric circuit in order to overcome the restrictions. So this heating effect is due to the work itself, or we can write W is equal to I square RT, and hence H is equal to I square RT. So simply the work done by the circuit in order to maintain a flow of current through it, that is changed into the form of heat. Therefore H directly proportional to I square RT, hence we can write H is equal to I square RT, and this equation is known as Joules equation of heating. Joule effect of heating, the equation for representing the Joule effect of heating. Why it comes in the name of Joule is that he discovered this thing, that is by doing some experiments he found that heating effect of an electric current is directly proportional to the square of current passing through the conductor and the resistance of the conductor and to the time of the conductor. Therefore, that is James Prescott Joule. He found this. So in order to honor him, we give this Joules law of heating. So this equation is called Joules law of heating, and this equation is known as the equation for Joules law of heating. Hope it is clear for you, and thank you for watching.